So we'll start soon. All right, so what we're going to be doing today is we're going to be doing fluid power practice problem answers that you did on Friday in breakout rooms, okay? So if you would open your practice problems. So let's see what we got. So for the first one, it says a mnemonic system is producing a 100-pound inch cubed squared of a gauge pressure. Cylinder is needed to press an adhesive label onto a product. It has determined that it's 5 pounds of force. Is optional to complete the task. Sketch the label. So we have a mnemonic system. If we have a mnemonic system, that means we have what's this called? What is this? Do y'all remember what this was? In your systems? What was that? What is this? What am I drawing here? It's a piston, right?
Oh, yeah.
Remember, this is a piston. Okay, so for a piston, it says that it is 100 pounds inch squared, okay? And it wants to go and take and do a label, which is your product. And it's supposed to be 5 pounds. So your first one should look just like this. Since it says that it's a mnemonic system, if it's a mnemonic system, that means that it is a piston, okay? It tells us that it's 100 pounds inch squared, and it's a cylinder, and it needs to heat a product of 5 pound force to optimize it. So here's your product. It has to apply 5 pounds. Do you understand how to draw this and why I drew it as a piston? Okay, so let's look at number 2. What is the required area of this mnemonic cylinder? So my formula is P equals F over A. What does F stand for?
F is force.
Force, okay? Now, if you look here, the piston had to apply 5 pounds of force onto the label, right? So that is 5 pounds. Do we know what the area is? Okay, so the area is the question mark. Do we know what P is?
Yeah, it's 100.
100 pounds per inch, right? Okay. So since we know that, that's P equals F, which we decided F was 5 pounds, and A, we don't know what it is, right? Okay, so how do we handle this?
You do.
Cross multiplication, correct?
So it would be A equals 5 over 100.
Okay, so it would be 5 pounds over 100 pounds inch squared. And so what I would like you to do is pull out your device and open up in your device the calculator so you can learn, make sure you know how to do the calculator. So what you need to do is do alpha y equal, right, to make your fraction. You're going to do 5 over 100, and you should get 0.05 inches squared. So when you get your calculator up, do alpha y equal, which will give you a fraction. Do 5 over 100 and hit enter. what is the answer that you get? Okay, so it's 0.05. The units that I'm going to get is inches squared, and the reason that is for is because pounds over pounds cancel each other out. All right, everybody good with that problem? Number 3 says, what is required diameter of it? So to find that, first thing you have to do is figure out your formula. Your formula is area equals pi r squared. Why is it pi r squared? The piston is a circle, right? It's a circle. So for a circle, formula is pi r squared. How do we find diameter? 2 times the radius. Okay? These are 2 formulas that should be there. So if we have that, what do we have so far? Out of area, do we have an area? That's this right here, right? So 0.05 inches squared. And that's going to equal pi r squared. Do we know what the radius is?
No.
Okay, so to be able to find that, we're going to do radius equals square root of 0.05 inches squared over pi. All right, put that in your calculator. So what you're going to do, alpha y enter to get your fraction. Well, excuse me, square root first. Square root. Then alpha y enter 0.05 over pi. And you got to square this, right? All right, so what do you get? I get 0.028. So in your calculator, you're going to do your square root. Alpha y equal 0.05 squared divided by pi. I got 0.028, which I'm going to change it to 0.03. And I'm just rounding it up based on the numbers. Is everybody good so far? Okay? After I get that, I'm not done. What else do I have to do?
You have to
Find my diameter, correct? So it's 2 times r, okay? So what is my r? Yep. And after I times that, what do I get?
You do. What's it?
Yep, and that is the answer. And that is number 3. Are you good so far? So what this was, it was talking about a piston, and what we were trying to do is we were trying to solve for everything that goes with that. So let's look at the next one. So the next one says, sketch and label the unknown and all the knowns. Hydraulic lift system uses 2 3-inch diameter cylinders. So hydraulic lift, the way that it works is you have these 2 cylinders. And you'll find out on Wednesday when you go in and you look at how a hydraulic lift works. So when you're drawing a hydraulic lift, this here is the thing you push up and down. Think of a car jack, okay? Over here, you have 2 pistons that lift it up. And this is where you put whatever you want on it, like a car or whatever, okay? So it tells us that P equals what? What is the system?
2,000
2,000 pounds.
over inches squared.
Yep. Inches squared, okay? What else do we have?
The diameter.
Diameter is 3 inches, and that's for each one, right? Okay? Next thing it's asking you, what is the area of the piston? Here we go again. What did we use for area before? Okay? Pi r squared is what we used before. So if we're looking for, first of all, the diameter, do we have anything that we can find out for the diameter? What do we have? We know the diameter is 3 inches, right? 2 pi. All right. So if we do that and we're looking for r, we're going to do 3 inches over 2, which is going to give us 1.5 inch. So what I'm doing is I'm taking what I know and I'm getting 1.5 inch. And after I get that, then I can find, yep,
We would do pi 1.5 squared
very good.
equals, I got 7.07
Yes,
inches.
perfect. Good so far. Okay, let's look at the next thing we're looking for. What is the system's capability of the lift? So we are looking for P equals F divided by A. Do we know what P is? What is P?
He is 2,000.
2,000, right? Because it has right here on our little thing here. So 2,000, and that's pounds per inch squared equals, do we have our force?
No.
We got to find our force, right? And then area. Do we have area?
7.0.
Fantastic. So if we're looking for force, we're going to say, all right, force equals my P, which is 2,000 pounds per inch squared, times 7.07 inches squared. All right, put that in your calculator and let's see what we get. What do you get? So you're doing 2,000 times 7.07. Yep. So you get 14,140 pounds. Now that we have that, what do we need to do next? Fantastic. So we're going to take our 14140 pounds, multiply by 2. So if we do second answer times 2, I get 28280. All right, so how is this one different from the last one? Is there anything different?
Not really.
No. Are they both hydraulic systems?
Yes.
Okay, so we're good so far. So we saw 2 different types of sketches, but we did the same thing, right? All right, let's look at our third problem. Our third problem says a gauge pressure of pneumatic system reads 200 pounds inch squared when the volume is 30 inches cubed, the cylinder is compressed until its gauge reaches 60 pounds per inch squared. Pneumatic cylinder, what is going to be it? What's it going to be? A piston again, right? Piston again. So let's draw us a piston. Now, what do we know about this piston?
We know the V1 is 30 inches.
Okay.
We know
V1, you're right, 30 inches cubed. What else do we know?
V1 is 20 pounds over inches squared.
Okay. What else do we know?
We don't know V2,
Right?
and we know P2 is 60 pounds over inches squared.
Okay. So what gas law are we going to use? Boyle's law, right?
Yeah.
Boyle's law, pressure 1, volume 1, pressure 2, volume 2, right? What we got up here, right? Do you see it right there above Isabel's thing? So, P1 V1 equals P2 V2, right? So, for the first one, we're looking for absolute pressure before and after the cylinder is compressed. All right, so I already have everything kind of figured out, but right now, I need to find out the pressure of the absolute pressure, ABS, equals pressure of the gauge plus what? Yes. How do we know that? Because that's what it's supposed to be. Remember, when we're doing these gas laws, the difference between this class and a normal science class is we have to find, for our absolute pressure, we have to take our gauge plus this constant number. All right? Add them together and tell me what you get. So what is the pressure of the gauge first?
It's 20.
20 pounds, right? 20 pounds inch squared plus 14.7 pounds per inch squared.
It's 34.7.
34.7 pounds per inch squared. Perfect. What else do we need to do beside that one?
60.
We need to do the second gauge, right?
Yes.
Yes. So P absolute pressure gauge number 2 plus 14.7 pounds per inch squared. 60 pounds, right? 60 pounds per inch squared plus 14.7 pounds per inch squared. What's that equal?
74.7.
74.7 pounds per inch squared. So the only thing we're doing there, we're just solving for absolute pressure. All right? The next one says, what is the volume of the cylinder after the gas is compressed? So we go back to our formula here. P1 V1 equals P2 V2. We're looking for V2, correct? So if we're looking for V2, we need to divide both sides by P2, right? So there's my formula. So P1, first pound, what is my first one? 34.7, right? I'm going to multiply that by my volume 1, which is 30 inches cubed. I'm going to divide that by my second pressure, which is 74.7 pounds per inch squared. All right, let's go to our calculator and see what we get. So I'm going to do alpha y inner, 34.7 times 30 over 74.7. What do y'all get? Did you get 13.935 74297. Fantastic. So my answer is 13, right? But if I go back to scientific notation, I'm going to round that back. I'm going to round that one to 14. Okay? Everybody good with that? Are you good, baby? Fantastic. All right, I'm going to erase this. So this one here had to do with, did it have to do with fluid pressure or harmonic pressure?
The second one is good.
So it has to do with fluid pressure. How do I know it's fluid pressure? Because it uses a gas law, right? Gas law, fluid power. Got it. Okay, let's see what next we got, which is a mnemonic. The next one says that an air temperature of 28 inches cubed containing a free-sliding piston is initially 45 degrees Fahrenheit and the temperature is raised to 200 Fahrenheit. All right, so mnemonic system again. What are we going to draw again?
The piston.
Another piston. Okay. What do we know about the piston?
We know that V1 is 28 inches cubed.
Yep.
T1 is 45 degrees Fahrenheit. V2 we don't know, and T2 is 200 degrees Fahrenheit.
Okay. So what gas law are we using this time?
Gold. Charles.
We're using volume and temperature.
Gaze.
It is Charles's law, right? Well, volume and temperature, right? This is Charles's law. Okay. What does Charles's law say? V1 over T1 equals V2 over T2. And what I've told you before, make it linear. It's easier that way. So V1 T2 equals V2 T1. Only thing I'm doing is crisscrossing and making it. What is the first thing we have to do with these temperatures first? Convert to?
Yes, by adding 460.
Convert it to Rankins, correct. So the first thing I'm going to do is I'm going to take my temperature 1, which is 45 degrees Fahrenheit, plus you said I'm going to add 460 to it to get my Rankins. So what is my temperature 1?
Your temperature 1 is 505.
505. Temperature 2?
60.
And I'm going to take my 200, right, Fahrenheit, plus 460, and you said 660, right?
Right.
Okay. So for this gas law, we're going to convert the temperatures. Is the volumes okay? Yes. Only thing we're going to do is when we're doing these, we're either going to be changing the pressure, right? Gauge pressure with absolute pressure, temperature from Fahrenheit to Rankine. All right, so the next thing it says, what is the volume of the cylinder after temperature has been raised? So we've got our formula. We're looking for V2, correct? So let's take T1 out of this side, T1 on this side, and there's my formula. V1 T2 divided by T1. My volume 1 is 28 inches cubed. Multiply that by my temperature 2, which is 660 Rankine. And I'm going to divide that by my temperature 1, which is 505 Rankine. And let's get our calculators out. Let's do our alpha y equal again. We're going to do 28 multiplied 660 over 505. And what did you get? Yep. 36.594.
Wouldn't you round it to 37?
Yep, and you ran it to 37. And my answer is in inches cubed, correct? So starting to become clearer. I think so too.
This one's not that hard.
No, it's not.
Or easier than all of
It is so far that we have. So what's the next thing we have to do?
For the next problem?
So the next one, we're going to do the next problem. Very good, Kate. Thank you. Are you good, Amanda? Can I race? Okay. So for number 13.
Draw another picture.
Okay, so it says here, a compressor tank contains a gauge pressure. That's 160 pounds per inch and a temperature of 70 degrees Fahrenheit. At some time, the temperature decreases to 40. So if you've ever seen a tank, it's usually square, right? You're going to have two gauges that are on the outside. What do we know?
We know that there are two gauges. We know that the T1 is 70 degrees Fahrenheit.
70 degrees Fahrenheit.
T2 is 40 degrees Fahrenheit.
40 degrees Fahrenheit.
P1 is 160.
P1 is 160 pounds per inch squared. And what is the volume of our air tank? 60 feet cubed. Very good.
Can I use the bathroom?
Sure, go ahead. So the first thing we have to do is we're looking at our temperature, right? So we're going to have to change our temperature to Rankine. So temperature 1 equals 70 degrees Fahrenheit. We have to add 460 to get our Rankines. Our temperature 2, we got to take our 40 and add 460 to get our Rankines. So for that one, I got 530 Rankines. And for the second one, I got 5.0 times 10 to the second Rankines, or let me do my calculations. Whoa. Oh, I'm timesing. Dang. It's going to say 500 Rankines. Is that what you got to? I'm going to keep it that way instead of scientific notation. But if you wanted to change the scientific notation, the only thing you had to do is go to mode, go to scientific, second answer, enter, and that's 5 times 10 to the second power. Okay? Next one says, what is the absolute pressure of the system before the temperature decreased? So our pressure was 160 pounds per inch squared. What do we have to do about the pressure? That was the gauge, right? So if it's gauge, we have to add what to it to get that? 14.7 pounds per inch squared. So if we did that, what is our pressure? 174.7 pounds per inch squared. So that is our pressure according to the gas laws. What is the absolute pressure of the system as the temperature increases? So what gas law are we using this time? Gay-Lussac. So for Gay-Lussac, as it says over there, it says P1 over T1 equals P2 over T2. So since this is Gay-Lussac, we want to make this linear. So if we make this in there, that's P1 T2 equals P2 T1. What are we looking for? Our second pressure, right? Let's take T1 off this side, T1 off this side, and now we have our equation. So our first pressure is 174.7 pounds per inch squared. We're going to multiply that by our second temperature, which is 500 Rankine. And we're going to divide that by our first temperature, which is 530. And let's see what we get with the math. Alpha Y inner, 174.7 times 500 divided by 530. I got 164. What did y'all get? Okay, so the answer to that one is 164.8 pounds per inch squared. They rounded it to 160 pounds per inch because our deciding factor, we're rounding there. Question about number 16. Good? Fantastic. So all of that has to do with our fluid power, has to do with gas law. So in that unit, what we did is we did a Charles law, we did a Boyle's law, and we did a Gay-Lussac law. All three of those having to do with engineering. Okay. Next one. Flow meter is attached to a hydraulic line that measures 12 gallons per minute. The line has an inside diameter of 1.5 inches. So we have a line and we have a flow meter. This is what a flow meter looks like. It says that the flow meter is 12 gallons per minute. And the diameter of the line is 1.5 inches. That's the way it should look, okay? So the next one says, what is the flow rate measured in inches cubed at the meter? So 1 gallon per minute equals 231 inches cubed by minutes. So this is my conversion. Do you have that written down somewhere? If you don't, you need to write that down, okay? So what we're going to do is we're going to take our 12 gallons per minute, and we're going to multiply that by our 231 inches cubed by minutes. So if we take 12 times 231, I got, let's change that to scientific. I got 2772. And that is inches cubed per minute, because that's what it asked for us to do, right? So if you wanted to round that up, that would be 2,800 inches cubed per minute.
Wait, I got 2.7.
Right.
No, I didn't.
You good?
Yes.
Okay. So the next thing it asks you is the area inside the diameter of the line. So now what we're trying to do is we're trying to find this area. All right. What formula do we use again? D equals 2R. Area equals pi r squared. What do we have so far? We have the diameter, right? 1.5 inches equals 2R. The next thing we have to do is we need to solve for R. So for solve for R, we're going to do 1.5 inches divided by 2, which will give us what? Alpha Y inner. 1.5 over 2. 0.75. And that's my radius. Once we find our radius, what are we going to do?
The area,
Yep.
which is pi 0.75 squared.
Very good. Okay, so let's do our calculation. Do our pi 0.75 squared. And what do you get? Yep. 1.767145868, which will equal 1.8 inches squared. We good so far? All right, for number 20, it's asking us for the flow velocity. If we're looking for velocity, what formula are we going to use?
Velocity formula.
Yeah, Q equals V times A. Do we know what Q is?
Q is the flow rate.
Okay, what was the flow rate?
The flow rate is, hold on. The flow rate is 1.5.
No.
2.72.
There you go. 2.2772. And we're going to equal, do we know what V is?
No.
No. Times what is our A?
1.72.
Yep. Squared, right?
Yes.
Well, it's inches squared, but we're just doing inches squared as my unit. Okay. So if we're looking for that, what are we going to do now? We're looking for V. V is going to equal Q divided by A. And what do we get for that? Alpha Y equal.
I think I did it wrong just because I did the I got number 18 minutes.
No problem.
And I put 2.72.
Okay, that's fine.
instead of
So it's 2772 is the top number, and we're dividing that by 1767. And we are getting 24 divided by 589. I got 1.56. So what you got in mind?
I didn't do that.
Oh, okay. That's fine. So that is my answer for Q is 1566. Okay?
That's what I got, but I don't know how I got that.
That's good, Kate. So what is this one?
Maybe I just wrote down the decimal.
You probably did.
Or I changed it.
Changed it to a point instead of a
I
decimal.
don't know what I did.
All right, well, what is this from? Is this from fluid power or hydraulics?
No.
Hydraulics, right?
Yeah.
Fluid has to do with gas laws, right? Hydraulics does not. Are we good? All right.
Okay, so okay.
You get it? All right. Well, let's see. Because if you think all the rest of them, Kate, had to do with gases, right? This has to do with oil. And when we're talking about oil, we're talking about hydraulics. Okay, next one. Hydraulic press. What do you think this one's going to be on? There we go. Is used to fit two components together in an assembly process. The system must generate 775 pounds of force and performed at the press fit. The piston of the input cylinder is pushed with a force of 250 pounds and has an area of 30 inches squared. The output has a 15 cylinder with a 30. So this has to do with fluid. We are going to use syringes. And then we have a line that goes to here. All right, so what do we know so far? This area here for this piston, which is my piston 2, is 30 inches squared. Do I know anything else about this piston? Or better yet, this syringe? What is my F out? 775 pounds.
Yeah, that's what it said.
Yep. It's okay. All right. So this one is my N. So what is my F in?
We don't know.
No, we do know.
That's a good question.
250, right?
Yes.
Yeah.
I thought the other thing was
It's okay. We're good. Okay. So we have this one going in at 250 pounds, pushing that air through or that fluid through till it goes to here, sorry. And this one is going out at 775 pounds, and the area of this one is 30 inches. What is the mechanical advantage required to gain the necessary force? All right, we're going to use either IMA or AMA. Which one are we going to use? Okay. F out over F in, correct? Trying to find the mechanical advantage. What is our pounds out?
775 over 250.
And what does that equal?
3.1.
3.1. Questions? And then the last one, how many output cylinders must incorporate into this design? That would be 4 cylinders.